Before I start connecting cables and connectors, let me go over the pads and how we can connect them. So let's start from the left hand side, which is the power output side. There wasn't enough space on top of the PCB to mark everything, so I was only able to mark the negative side of the pad sets. So this is the negative, this is positive, there's a separation mark, negative, positive, it goes like that up to the top. There's also a marking at the bottom side. So this is the horn, minus plus, minus, this is L plus, which means the low beam. This is high beam, daytime running lights, DRLs, brakes, left blinker, right blinker. So this is the main input for the 12 volt and the ground. So whatever this plus means, it is actually equal to this voltage. So if this is 12, the plus side is going to be 12. If this is 5 volts, this is going to be 5 volts as well. It's because you can run the whole board instead of 12 volts, you can actually run it on 5 volts if you want to. Okay, let's move on with the RGB strip connection. It is pretty straightforward, but there is some information about the voltage. So this is the voltage plus, this is the ground, and this is the signal pin. So if your RGB strip is 5 volts and your system voltage is 12 volts, you can actually connect it, but you're gonna have to connect your 5 volt voltage source to these pins, 5 volt and the ground. And then this pad becomes 5 volt. But there is another way around. If your RGB strip is 12 volt and your system is 12 volt, you can actually use only these pads to feed the boat. So let me show you here that if you bridge this P dot bridge, solder bridge right here, it is going to bridge this 12 volt to the voltage plus pad. And in that case, you won't have to use these pads. It's up to you. You can actually feed 12 volt from here as well. So there's so many possibilities. As we are moving to the right hand side, this is these pads are for the UART connection for the screen module. There wasn't enough space on top again to mark everything, but there are markings at the back side. For example, this is the high-low headlight, which is on the inner top side. As you can see, there's high marking, low marking, and the minus marking. And left right blinkers, right plus, left plus, minus. It goes all the way to the bottom, which is braking input. This is the plus minus, and the battery input. To measure the battery, you can feed up to 110 volts on these pads to measure the voltage. Let me go over the braking. This is how you can detect the braking. I didn't know much about how braking works in e-bikes, but according to my observation, at least in my bike, there is a mode that when the controller senses a signal from the brake lever, it actually cuts power on the motor as well. So let me show you how you can preserve that mode and still connect the brake line. So in my e-bike, this is the brake lever, plus and minus, or minus and plus, it doesn't matter. In terms of brake lever, there is no plus minus. But on one of the sides, I measured 60 volt DC. And when the brake lever is not pulled, the other pin is just floating, it's just 0 voltage, but it is not actually connected to ground. So what we can do is, if we bridge this middle pin to the 1 position, let me show it better maybe here. So this middle pin, if it is bridged to the position 1, you can actually feed about up to 110 volts DC to the plus side. So what we're gonna do, at least on my bike, I'm not sure how any other bike works, but we're gonna take pad plus and connect it to the floating. Since this pad is actually pulled down, it will, even if it's floating, it's just gonna pull down and deactivate the brake sensing, which is perfectly fine. This is going to, when this switch goes down, meaning when you pull on the lever, this volt is going to transfer to this one, which was floating, but now it is going to be 60 volt, and it's just going to pull up the pad and it will activate the braking. This is the complicated way, but there's another way, which is just works like a switch. Because some people like to disconnect the brake lever altogether, and what we can do is just take the brake lever, plus minus doesn't matter in this case, because it's just going to be isolated from the rest of the system. You wanna bridge to the second position, which is here. Let me show you, from middle to the upper side, which is the second position. And in second position, we are actually using the microcontroller's logic voltage, which is 3.3 volts. In this case, we're gonna connect either one of the pads to either one of the brake lever holes. So let's say this is the pad plus, goes one of the cables, it could be plus minus, doesn't matter, and the other one goes to the other one. It's just a direct connection. This is how you're gonna connect the braking, and that is pretty much it. So yeah.